Hello guys, welcome to our video. Today we will teach you how to get directional derivatives. But first, let us define what is a directional derivatives. Directional derivatives. We extend the concept of a partial derivative to the more general notion of a directional derivative. We have seen that the partial derivative of a function give the instantaneous rates of change of that function in directions parallel to the coordinate axis. Directional derivatives allows us to compute the rates of change of a function with respect to the distance of any direction. For a function that is differentiable at a point, directional derivative exists in every direction from the point and can be computed directly in terms of the first order partial derivatives of the function. Theorem: if f of x and y is differentiable at x sub o and y sub o, and if u equals u sub 1I plus u sub 2j is a unit vector, then the directional derivative exists and is given by the equation number 4. And if f of x, y, and z is differentiable at x sub o, y sub o, and z sub o, and if u equals u sub 1I plus u sub 2j plus u sub 3k is a unit vector, then the directional derivative exists and is given by the equation number 5. Now, let's solve a problem. Find the directional derivative of f of x, y, z is equal to 3x to the 5th y squared z squared at the point 2, -1, 2, in the direction of the vector a equals 1 over 3i plus 2 over 3j minus 1 over 3k. First step, write the given. Next step, write the partial derivative of x, y, and z. For x, the partial derivative is 15x to the 4th y squared z squared. For y, 6x to the 5th y z squared. And for z, 6x to the 5th y squared z. After that, we substitute 2, -1, 2 to x, y, z of the partial derivative, and for x, we get 960, for y, we get -768, and for z, we get 384. Next step is to use the unit vector formula, which is u equals a over magnitude of a, because we will use this to get the directional derivative. The a will be 1 over 3i plus 2 over 3j minus 1 over 3k. The magnitude of a will be square root of 1 over 3 squared plus 2 over 3 squared plus -1 over 3 squared, which equals to square root of 6 over 3. And to get the unit vector, we will substitute the answers on the formula. And we get square root of 6 over 6i plus square root of 6 over 3j minus square root of 6 over 6k. And finally, we can get the directional derivative using the equation number 5. Which when we substitute will give us duf of 2, -1, 2, which is the points, equals to 960, which is the partial derivative of x, times the unit vector I, which is square root of 6 over 6, plus -768, which is the partial derivative of y, times the unit vector j, which is square root of 6 over 3, plus 384, which is the partial derivative of z, times the unit vector k, negative square root of 6 over 6, and it gives us negative 160 square root of 6. This ends our discussion. Thank you for watching. I hope you learned something from us. Subscribe!